I thought in answering this particular question, it would be best to have a video in which I go through at least two of the statements and then explain how they would be demonstrated using a Punnett square. Remember, the purpose of a Punnett square is just to show the possible outcomes of matings in terms of genotypes and then knowing the allelic interactions, the phenotypes. So you draw the square, what you're doing is showing the genotype, one parent being split in each one of these would represent a gamete. So this is the law of segregation, which says during meiosis, alleles of a genotype are separated and packaged into gametes. So the first parent in this case is heterozygous, the other parent is also heterozygous. So these represent the allelic content of parental gametes. And then when you put them together, it's representing an outcome of fertilization, and this would be a genotype of the progeny. So remember, in this case, we're talking about recessive inheritance, autosomal recessive. Okay, so it's not on a sex chromosome. You need two copies of the recessive allele in order to be affected. So let's take a look at the first statement. It says when both parents are carriers, remember, a carrier, excuse me, is a heterozygote. The individual has a copy of the recessive allele, but the phenotype is normal because this is recessive inheritance. Okay, it says when both parents are carriers, every child born to the couple has a 25% chance of being affected. Affected meaning being homozygous recessive, two copies of the recessive allele. So I've set up the Punnett square here. Again, my first parent is heterozygous, my second parent is heterozygous. So I have a 2 by 2 Punnett square. And then when I fill in the square, I get 1/4 homozygous dominant, 1/2 heterozygous, and 1/4 homozygous recessive. Now, in recessive inheritance, if you have two recessive alleles, then the individual is affected. So we can see 1 in 4 outcomes would be affected, and 1 in 4 is 0.25 or 25%. So you can see how the 25% number comes about. Now, can one of the common mistakes students make in talking about this is saying, well, okay, if 4 children are born to a couple, then one of them has to be affected. No, it's flipping the coin each time basically, so it's a unique event. So this couple could have two consecutive children that are born that are affected, but the odds of that would be 1/4 using the and rule, 1/4 or 1/16. So the probability that a couple would have two consecutive children born would happen on average 1 in 16 times. So I just want to make sure that's clear. So when both parents are carriers, every child born has a 25% chance of being affected, and that's illustrated here. Now, another way we could phrase this, a different question, would be what's the probability that a child born, an unaffected child born, would be heterozygous to this couple? Well, if the child is unaffected, we know that this genotype isn't a possibility. So I have these three to consider. Two of the three are heterozygous. Therefore, the probability that an unaffected child born would be heterozygous would be 2/3 or 0.67 or 67%, whichever you feel comfortable with. Now let's go to the second statement. When one parent is a carrier and the other isn't, every child has a 50% chance of being a carrier. No child will be affected. So again, I set up my Punnett square. I have one parent being heterozygous, the other parent being homozygous dominant. It's not a carrier. And they don't tell you it's affected, so we know it's a homozygous dominant. And again, I fill in my squares. Right? So let's look at the statement. Every child has a 50% chance of being a carrier. Well, two of the four combinations are heterozygous, so that is 1/2 or 50%. No child will be affected. Again, that's not possible because in order for a child to be affected with autosomal recessive inheritance, there has to be two recessive alleles. Since this parent is homozygous dominant, there is 0% chance of the child being able to have two recessive alleles. So you would use the same approach for the other two statements, setting up a Punnett square that describes each one of those particular statements. So I hope this video was helpful in explaining the principles.